Hello, Royals. This is a kind of recap of lesson 4.2, what I would normally do to begin lesson 4.3. These questions are available on the top of the lesson file for 4.3. So make sure you have a read through them and do try them out on your own before watching this video. I suppose you could pause now. And we're back. Yeah, so let's try out these questions. How are 30 degrees, 150 degrees, 210 degrees, and 330 degrees related? Well, they're related in a lot of different ways. The easiest way to explain it, I suppose, is that they are all 30 degrees away from an x-axis, which maybe in more precise words, we could say they all share a related acute angle. Here's 30 degrees in standard position. Here's 150 degrees in standard position. Here's 210 degrees in standard position. And here's 330 degrees in standard position. And here are their related acute angles. That's 30 degrees. That's 30 degrees. That's 30 degrees. And that's 30 degrees. So how are their sine ratios going to be related? Well, the ratio of the y value to the r value for any one of these angles at any point along the terminal arm is going to be the same because there are similar triangles in here. Even though we're letting go of our SOHCAHTOA idea of only being able to use that for acute triangles, we can still build the idea of similar triangles in here. Sorry, I said that the ratio would be equal. We of course know that that's not true when the y value is negative, but the absolute value of that ratio would be the same. So sorry, the answer to number 1 would be that they have the same related acute angles. If you told me actually in more precise detail that their sine ratios all have the same absolute value, I suppose that's kind of answering question number 1 as well. Question number 2, I would say that all of these ratios have the same absolute value. We'll talk about sines, S-I-G-N-S, in a second. For example, it is not true that the sine of 30 degrees is equal to the sine of 330 degrees. That's false because the sine of 330 degrees is going to be negative. The y value is negative, so the ratio of y to r has to be negative. I could try writing in that the sine of 30 degrees is the opposite of the sine of 330 degrees, and that would be true. But it might even just be safer to say that the absolute value of the sine of 30 degrees is equal to the absolute value of the sine of 330 degrees. Question 3 says the cosine of 50 degrees is about 0.643. Explain and illustrate what this means. This is one of my favorite grade 10 questions when asked to illustrate and explain what this means. If a student draws me a picture of their calculator and says, look, there's this cosine button that when I press it, it tells me this number, that is giving me a very clear idea of how much they understand, which is very, very little. In grade 10, I think a lot of students get by just thinking that these are magical buttons that give you numbers that help you find angles. Let's make sure we understand what this means. I'm going to start with a sketch for number 3. I'm going to try my best to estimate 50 degrees. 50 degrees is a little bit larger than 45 degrees. We'll talk about 45 degrees today. It's kind of an important angle because it creates a right isosceles triangle. So I'll sketch 50 degrees out right there. Now, it does not matter how long this terminal arm is. Anywhere on this terminal arm, if I drop a perpendicular, an altitude, if you like, down to an x-axis, let's say the closest x-axis here, then the ratio of my x value to my r value will be constant. In fact, if you ask me to estimate this here, I would say, I already have the value, so I guess I'm kind of cheating. I would say that this distance right here is a little bit more than half of that. I would say it's about 64.3% of that radius. This distance right here, that x distance, is about 64.3% of that radius. It does not tell you a length, it tells you a ratio. These are trig ratios. Okay. So to explain and illustrate what this means, I would say for an angle of 50 degrees, the ratio of x to r on any point, or let's say for any point on the terminal arm, is about, I guess I'll change it to a percent, 64.3%. That's one way of writing a ratio. I suppose I could have said that the x value will be about 64.3% of whatever the radius is as well. And the last question is one way that if professors want to give you a question and make sure that you understand things instead of using your calculator, they sometimes will give you the value of one ratio and expect you to calculate or determine the value of the others. And sometimes students are really confused about how they're supposed to do this without a calculator. Well, we don't need a calculator to do this. Here's 50 degrees, and I'm told up here that the cosine of 50 degrees is about 0.643. If I draw the other four angles in standard position that have related acute angles of 50 degrees, 50 degrees short of 360 degrees would be 310 degrees. 50 degrees short of 180 degrees would be 130 degrees. And 50 degrees past 180 degrees would be 230 degrees. Hey, isn't it lucky that they're only asking us to find the cosine ratios of these angles that share the related acute angle? Yeah. So draw a couple of triangles on here if you like. Notice that in the fourth quadrant, your x value will still be positive and your r value is always positive. So I'm going to go ahead and say that the cosine of 310 degrees needs to be exactly the same as the cosine of 50 degrees. Let's start with that one. Cosine of 310 degrees is going to be about 0.643. What about these other two? Notice that my x value has to be negative in this quadrant, in quadrant 2 and in quadrant 3. My cosine ratios are going to be negative in quadrant 2 and quadrant 3. I am not using an acronym to memorize this. I'm sure if you do a search or even look in your textbook, you might find some sort of acronym about memorizing where ratios are positive and negative. That is not necessary, and it does not lead towards understanding. It's memorization is never a replacement for understanding. I can tell that the ratio of x to r is going to be negative here because my x value is negative. The absolute value of the ratio is going to be the same as the absolute value of this ratio. It's just going to be the opposite sign. So I'm going to say that the cosine of 130 degrees is going to be the same as the cosine of 230 degrees, which is going to be the opposite of the cosine of 50 degrees, which is going to be about negative 0.643. Okay. You do not need a calculator to do that. I mean, I used a calculator to get this number to start off. But if you're given that fact, you should be able to figure out the rest. In 4.3, we are going to be discovering exact values of a certain number of ratios without a calculator. Try that out and let me know how you're doing.